All right, you guys, so here is the graph from question 1 in the chapter 7 review. A says give the independent variable and the dependent variable. So hopefully we are remembering that, you know what I could write on here that might help you remember? Dry mix, right? So the dependent variable is the y, and the independent variable is the x. This is also the manipulated, and this is the response. I think that's what all the letters stand for. In any case, the independent is x, so in this case, independent is time, and the dependent is y, so in this case, it's the number of people in a store over time. The number of people in the store is the variable. I was just thinking to myself over the time of the day. B, during what times are the number of people in the store increasing? So during what times of the day is the number increasing? That would be, how about we do blue? It's increasing, it opens up and it starts increasing, and then it continues to increase to noon, and then it looks like it continues to increase until 1, and then it starts to decrease, and it continues to decrease. So the times that it is increasing is from 10 a.m. to 1 p.m. Okay, and this is not a point on the graph. This is interval notation. Okay, I believe, and I'll double check the test, but I believe this you could just write it out too. It's increasing. It's continually increasing from 10 until 1. But like I said, I'll look on the test and see what the question is actually asking. During what times are the number of people in the store decreasing? And that's going to be for the rest of the time, from 1 until 6 p.m. when it closes, right? Still decreasing. Oops, nope. Decreasing until 4, right? But then it stays the same, and then it's decreasing from 5 to 6. So in interval notation, what that looks like is from 1 p.m. to 4, okay, union with, okay, this is interval notation, union with 5 till 6. Okay. What's next? What time are there 10 people in the store? Well, let's see. The number of people is here, so at what time are there 10 people in the store? The interesting thing about this is it looks like there's going to be 2 different answers for this, right? One answer is going to be 12 p.m. and the other answer is going to be approximately 2:30 p.m. Okay. How many people are in the store at 2? So that looks like, I'm running out of colors to use, you guys. How many people are in the store at 2? That looks like it's going to be 15, right? At 2 p.m. If we go straight up, looks like, oops, yep, 15 people in the store. What time are there 5 people in the store? Oh, again, you guys, 5 people in the store. It's going to be 2 answers. Oh, and there was 2 answers for this too, right? 2 p.m. and... Oh, no, never mind. That wasn't it. Sorry. My answer stands. At 2 p.m. there are 15 people in the store. After that, at what time are there 5 people in the store? You're going to have 2 answers for that. I'm going to make that yellow because that's kind of the same answer. Here, at what time? 11 a.m. there's going to be 5 people in the store. And at 3 p.m. there's also going to be 5 people in the store. Okay. G, what time are there the least amount of people in the store? So that's right after it opens at 10 a.m. It looks like there's 2 people in the store. Looks like at the end of the day, they have to kick 3 people out when they close. What time are the most amount of people in the store? So that's 22, and that's at 1 p.m. Given the rate of change from 11 a.m. to 1 p.m., so I'm going to erase a lot of this color so we can start over, okay? Rate of change, remember, is slope. There is a formula for slope. It is y2 minus y1 over x2 minus x1. So these numbers match up. This y has to match with this x, and this y has to match with this x. Given the rate of change from 11 a.m. to 1 p.m., give the rate of change. Okay, so at 11 a.m., there are 5 people. This is a point. This is a point. This is x. This is y. And at 1 p.m., at 1, there is 22 people. But, and here's where we've got to be careful, you guys. We need to fix these numbers down here to not be the numbers that are here. Because 10 a.m. is a bigger number. 10 is a bigger number than 1, and we can't have that on a graph. So since it opens at 10, we're going to make 10, 0. We're going to make 11, 1. We're going to make 12, 2, 3, 4, 5, 6, 7, 8. So it's open for 8 hours. So we're going to change the 1. We're going to change the 11, first of all, to be 1. So that's tricky. And we are going to change the 1 to be 3, right? And you can view it on the graph. If you don't want to do the formula, you can simply look at what's happening on the graph. Remember, it's the rise over the run. So there's my run is 2 hours, and my rise goes from 5 people to 22 people, right? So if we use the formula, y, this is x1, y1, this is x2, y2, we're going to have 22 minus 5 over 3 minus 1 is equal to 22 minus 5 is 17 over 2. So if I split 17 in half, that is going to be 8.5. So that's my rate of change. Every hour from 11 to 1, we are gaining approximately 8, or on average, we're gaining 8.5 more people into the store. Okay, so that is from 11 to 1. Jay says from 1 to 5. So we need 2 more, and we can look at that. This is going to be a decreasing one, right? So from 1, which is actually 3, to 22, to 5, which is actually 7, which is 4 people in there. What's it going to be? So it's going to be, so this is x1, y1, x2, y2. It's going to be 4 minus 22, which is going to give us that negative slope because it's decreasing, over 7 minus 3. The difference, negative 18 over 4, which is equal to 4.5, I think, negative 4.5. You guys, please double check on your calculator that that is correct. I just did that in my head, but I said 4 can go to 18 4 times with 2 left over. 2/4 is 0.5. I know it's negative. And last, give the rate of change from 2 p.m. to 6 p.m. So I'm going to go, well, let's just erase some stuff. Okay, so from 2 p.m., 2 is actually 4. to 6 is actually 8. And again, it's going to be a decreasing slope, right? So 2 is actually 4, and at 4 there are 15 people, right? So x1, y1. And at 6 it's actually 8, and there are 3 people. And that's x2, y2. So 3 minus 15 over, that's going to give us our negative, right? Over 8 minus 4, which is 4. So negative 2 over 4 is equal to negative 1/2, or negative 0.5. That's going to be the rate of change from 2 to 6 p.m. Okay? Rate of change from 2 till 6. So, and I think there's only 2, oh no, there's 3 questions on this. So let's take a look at the next one. Describe what this graph is telling us about the relationship between the 2 variables. Well, what is our x is our heating time. Okay, so it's the temperature of heated water. So the longer we heat the water, the higher the water temperature goes, right? So the longer we heat the water, the higher the water temperature goes. All right, so up until 100, which is boiling, because we're using Celsius, because water's not boiling in Fahrenheit until 212 degrees, I think. Look that up, see if I'm right. Describe what this graph is telling us about the relationship. So the longer you heat water, the higher the temperature, right? When is the water temperature at 80 degrees Celsius? Well, at 80 degrees Celsius, it has been heating up for 3 minutes, right? So at 3 minutes, it is 80 degrees Celsius. I'm curious about what heat this water is on. I wish it was telling us that for more information. At 4 hours, what is the water temperature? Well, we're going to have to make an equation, right? These are not hours, these are minutes. So after 4 hours, what is the water temperature? This is going to be interesting because I think it's going to be wrong, given that once water starts boiling, it's not water anymore. But let me explain this. We have y equals, I don't know, what do you say this is, 50? Our starting value is 50. And our rate of change, we need to figure out our rate of change, but regardless, we're going to have 50 on the end here. So our rate of change, let's just say, let's pick a point here and go from here to here. So it goes up 20 degrees and it goes over 2 minutes. So our rate of change is going to be 10 degrees per minute, DPM. I don't know if that's a real thing, but that's what I'm going to put there. So it's going to be 10x and it's going up, so it's going to be positive. So 10x plus 50. If x is our time in minutes and we want to know after 4 hours, then we need to do 60 times 4, which is going to be 240 minutes. So y is going to be equal to 10 times 240 minutes plus 50. So y is going to be, if I add a 0 here, 2400 plus 50 is going to be 2450. So in 4 hours, the water temperature is going to be 2,450 degrees? No. Okay, that it's going to stop after 100. My best guess actually is that they meant to put 4 minutes here, in which case the answer would be approximately 90 degrees. But it's interesting that we could actually make a prediction if water didn't turn into steam, what the temperature would be. D says give the rate of change of this graph. Well, we just figured that out. It was 10 degrees Celsius per minute. Cool. All right, last question. describe what this graph is telling us about the relationship between the two variables. Well, we have at the bottom here the number of hours, so the longer something is happening, and what's happening is there is a candle, and we are measuring the height of this candle. So, obs, the longer that it is lit, the shorter it is going to get, and we can see that because it is a negative graph, right? It's coming down. Give the rate of change for this graph. Okay, so we can either just draw it in. It looks like it's perfect. We're perfectly capable of finding a couple of points. Even this first one, it looks like it goes down 1 inch every hour. So literally it's the slope or the rate of change is 1. With units, that would be 1 inch per hour. Do not forget, if we're just using numbers, negative. That's an ugly negative. Negative 1 inch per hour because it's getting smaller. Let's go ahead and write the equation for this. I know it's not asking, but we might as well. So we have if x is equal to the number of hours and y is equal to the number of inches, then the number of inches is equal to minus 1 inch per hour, plus we start with a candle that is 10 inches high. So in 10 hours, if it's on lit for 10 hours, it will either burn out, or if you are Miss Binkley and it was your first apartment, you come home and you've almost lit something on fire because you left a candle burning while you were away at work. So be careful with that. I look forward to seeing you tomorrow. Please come with any questions that you have.